Okay, guys. So today, my dear students, we are going to start with the next part. So last time you know that we had started with the polymerization. So in the polymerization, we were doing the condensation polymer, and the first condensation polymer that we had done, that was the polyamide and nylon, and we have done different types of the nylon. Okay, so I have given you some of the nylon to practice. Okay, so let's draw one more nylon up here. Nylon 68. Okay. So nylon 68, my dear, I told you that these numbers, they actually show the number of carbons in the two monomers. Okay. So 6 meaning that there are the 6 carbons in the first monomer. Okay. So you got C, you should write CH2 like that, and then make the acyl chloride on both sides, because I told you last time that the first monomer used in the formation of nylon, that is acyl chloride on its both sides. So you should make the 6 carbons in the acyl chloride. So we got 2 carbon up here and 4 carbon up here. So 4 carbon and 5 and 6. So 6 carbons in the first monomer. Okay. Now you should take the 8 carbons in the second monomer. So CH2. Okay, write NH2 on its both sides like that. Because for the nylon you need acyl chloride, diacyl chloride. So this is diacyl chloride. And this one, my dear, it contains the amine group on its both sides. So this is the diamine. So these things they are going to repeat again and again. So diacyl chloride, diamine. Then again you should draw diacyl chloride. So CH2 4 times, C double bond O, Cl, and this is C double bond O and Cl. And then again you should make the diamine. So this one is continue on both sides. Okay. So now what would happen, beta? The H from the amine and the Cl from the acyl chloride, they are going to form HCl. So H from here and Cl from here, they would form the HCl. Okay. So now you will get n number of HCl. Okay. And join all of these. So this is CH2 4 times. Okay, on its both sides you got C double bond O. So draw the C double bond O on its both sides. Okay, and then join this one with NH. NH. This one contains the 8 carbon. So this one nitrogen, nitrogen. So 8 carbons are present up here, because this second thing shows the number of carbons in the second monomer. So 8 carbons. So here you should write CH2 8 times and NH. So CH2 4 times is surrounded by the C double bond O, and CH2 8 times, that is surrounded by the NH, and just continue it. So again you got C double bond O, CH2 4 times and C double bond O. Okay, and then you got NH, CH2 8 times and NH. So continue this whole thing. Okay, so this whole thing, my dear students, that is called as the nylon 68. So nylon has got different kinds due to the different number of carbons into the two different monomers. N हमेशा लगा है। जी N हमेशा लगा है। Okay, so this is my dear nylon 68. Now one more thing. Keep remember, my dear students, that the carbon chain in a polymer that makes a polymer elastic. Okay, I think all of you have seen the rubber band. If you just push it, it will expand, and if you just leave it, it will come again on its original position. So this this carbon chain makes a polymer. So nylon 68 that is elastic. Why? Due to presence of carbon chain. Okay, so in the paper, most of the time he wants to ask you if you want to make the nylon rigid, okay, not the elastic. So what should you use? So there is only one method, my dear, and that method is if you change this carbon chain with the benzene group. Okay, so then let's suppose this carbon chain I'm going to replace this carbon and hydrogen chain with benzene group like that. Okay, and then you got NH, and then this carbon and hydrogen chain we should make the benzene group again. So carbon and hydrogen chain they are replaced by the benzene group. Okay, so this type of the polymer that is formed, this is called as the, this is also having the amide linkage, but this is called as the Kevlar. Okay, and this is the rigid one. It is also the nylon. Okay, this is also nylon, but this special nylon that is called as the Kevlar, it is rigid, it's not elastic, and this one Kevlar has got the uses in the bulletproof jackets, okay, and it is used in suitcases as well. Its suitcases they are very expensive. Okay, the suitcase made up of the Kevlar. Okay, so Kevlar it is used in bulletproof jackets and it is used in the suitcase. Why? Because it is rigid. Okay, if the carbon and hydrogen chain is present in a nylon, so that will make the nylon as elastic. Did you get it? Okay, the next thing, my dear, we are going to start that is the polyesters. So, what are the polyesters? Polyesters, you know that you people have read the esters. Esters, they are formed by the reaction of carboxylic acid with the alcohol. Okay, so as a result, you will get the ester and water. Okay, so now I told you at the place of carboxylic acid, you could use the acyl chloride. Acyl chloride. So they are more reactive. So if you react the acyl chloride with the alcohol, you can get the ester as well. Okay. So now for polyester, what should we do? We should take a long chain of carbon and hydrogen. I'm not going to specify the carbon and hydrogen chain. I'm going to make a box up here. And on its both sides, I'm going to draw the acyl chloride. So this is, my dear students, the diacyl chloride. Diacyl chloride. Okay. And the next thing that is alcohol. So alcohol. So if you see another carbon and hydrogen chain like that, so this is having the alcoholic group on its both sides. Okay. So this is di-alcohol. So these two kinds of the monomers they are used in the polyesters. Yeah, it is diol, but I'm just making you understand about it. This is di-alcohol got the two alcoholic group. It is diol, of course. Okay, so they are alternatively repeating. Again, you got the diacyl chloride on its both sides. Okay, and then again you got the di-alcohol. So one box is white and one is shaded. So why? Because this one contains a different carbon and hydrogen chain. This one contains a different carbon and hydrogen chain. Okay, so now what would happen? The H from here and Cl from here, they would form the HCl. H from here, Cl from here, they would form the HCl. H from here and Cl from here, they would form the HCl. So Cl and H, they would form the HCl. And just like that, H from here and Cl from the other, they would form the HCl. Okay, so you will get a large number of the HCl molecules. N number of HCl molecules. Okay, now this is the white box and C double bond O on its both sides. Okay, and then you got O and then shaded box and then O. Now have a look up here. White box is surrounded by C double bond O and shaded box is surrounded by OO and just continue it up. So again you got C double bond O, white box and C double bond O. Then O, shaded box and O. So this whole chain formed, my dear, that is called as it is having the ester linkage again and again. So this linkage is called as the ester linkage. This is the ester linkage, and this ester linkage is going to repeat again and again. So these type of the molecules, they are called as the polyesters. Okay, polyesters. And one of its example used, that is, my dear, terylene. Okay. Now, what is the terylene? Okay, so I'm going to change this one, this one with benzene. Okay, this one is with benzene, and this thing that would be CH2 and 2 times. Okay, so this is basically diode. So this is ethane 1,2-diol. Okay, so this is benzene. This is benzoyl chloride, dibenzoyl chloride. Okay, so this is dibenzoyl chloride. So this one is going to change. Here we got again benzene. Okay, and here we got CH2 2 times, like that. So if you join them, my dear, so this one would become benzene. Okay, and this one, that would be CH2 2 times. And this one again, benzene. And this one, CH2 2 times, like that. So this whole thing, my dear, that is called as the terylene. So this is the structure of the terylene. Okay, this is terylene. Now, we are going to do a special type of the polymer which are called as the conducting polymer. I think you people have seen some of the polymer which are conducting polymer. Why? Like metals, they are not very, they are not very heavy. So polymer, they are just like the plastic type of the thing, and they can conduct the electricity. Okay. So what are the conducting polymer? In the conducting polymer, you got like this one, benzene group. In benzene group, you got the alternatively double bond, like that. Okay, and this one is joined with this, and this one is joined with again benzene. So this one is continued on both sides, guys. So if you look at this polymer, just listen very carefully. This one is having the alternatively double bond. So these are the electrons. Okay, so this one all containing the alternatively double bond, like that. So this electron could jump up here, this one could jump up here, and it can form double bond up here. Okay, so this one could jump up here, this one could jump up here, it could form double bond up here. Okay, so this one could jump up here, this one could jump up here, and it can form double bond up here. So the electrons, they can move by jumping from the alternatively double bond. So when the electrons, they are movable, so it means this is called as the conducting polymer. It can conduct electricity. So you people have seen, the mobile phones, they are becoming very light in weight, because that mobile now using the technology, the conducting polymer, okay, in which no metals they are being used. So conducting polymer, they are very light in weight, okay. And what happens in the conducting polymer? The rule is that you got alternatively double bond like that. So electron can jump and they will become delocalized, and this whole thing will, this one up here and this one up here, okay. So they can form double bond up here. So electrons would transfer from one end to another end by the delocalization process. So in this way, they can conduct the electricity. Did you get it, guys?
Yes, sir.
Okay. The second type. So this is the first kind of polymer. फिर ये भी आगे नहीं बनेगा वैसे नहीं. Sorry. यार ये बनता चला जाएगा ना, आगे तुम्हें बोला तो है कि बेंजीन बना दो, चलता डबल बॉन्ड्स को चेंज करके जगह तो वो भाई देखो ना, चेंज करके ये वाला इधर आ गया, ये वाला इधर आ गया, तो ये यहाँ पे डबल बॉन्ड आ गया, ये वाला इधर चला गया, ये वाला इधर आ गया यहाँ पे, तो ये इलेक्ट्रॉन शिफ्ट होते जा रहे हैं यहाँ पे, बता तो रहा हूँ. The shifting of electron from one place to another place, that is going to take the electricity. लेकिन वो कब हो सकता है? When you got alternatively repeating double bond like that. Okay, you got it? Yeah, you have to draw it. Conducting polymer. Okay, then interlinking molecules. Okay, guys, so this is the new term. Let's suppose you got the two chains up here. These are the polymer chains. So these chains contain the carboxylic acid group. Let's suppose carboxylic acid group. Okay, this one is also containing carboxylic acid group like that. Carboxylic acid group like that. Let's suppose. Now you can interlink these chains by putting some small molecules in it. Okay, so these carboxylic acid, they can react with the alcohol. So you can take any of the alcohol. So let's suppose we got CH2. It got alcohol on that side, alcohol on that side. Okay, so the OH from here, H from here, that is going to form water. OH and H, that is going to form water. So that water would be removed. That water would be removed. Let's suppose. Okay, now this one is joined with it, and this one is joined with it, like that. Are you getting my point? So now these two polymer chains, they are linked together by this one interlinking molecule. So you put some molecules between the different polymer chains depending on the groups they got. Let's suppose there is another two polymer chain. Let's water कैसे निकला जी? यार ये कार्बोक्सिलिक एसिड ग्रुप थे ना भाई, कहा तो है कि कार्बोक्सिलिक एसिड ग्रुप है, ये कार्बोक्सिलिक एसिड ग्रुप है. तुमने एक चेन ले ली जिसमें अल्कोहल ग्रुप दोनों साइड में लगे हैं, ये लो, तो ये अल्कोहल और कार्बोक्सिलिक दे वुड फॉर्म ये OH और H मिलके वाटर बन गया, OH और H मिलके वाटर बन गया, तो इसको मिटा दो तो ये बीच में लग जाए. Now, if you got a chain in which the alcohols group are present, alcohols, let's suppose. Now you should put a molecule in between it which contain the carboxylic acid group on its both sides. Carboxylic acid group and carboxylic acid group. Okay, so now what would happen? the OH from here and H from here, that is going to form water. So the OH from here and H from here, they are going to form water. Okay. So now just rub this one, water molecule. Rub this one from here, the water molecule, and they are joined together like that. Okay. So this molecule, that is the interlinking molecule. Interlinking molecule. Did you get it?
जी सर.
Yes, sir.
Interlinking molecules are the molecules depending on the different groups in a polymer chain. If that polymer chain contain carboxylic acid group, you should add some alcoholic group up here, which will join the two chains together. So the two chains, they are joined together. Okay.